All right. My name is Jeff Mieleff. I'm a senior program manager. Oh. All right, we're going to make one more announcement. So if you're here for WCL 306, the Virtualizing MDOP session, that's in Hall 3A. Apologies for the last minute room changes, but we actually got a lot more interest in Virtualizing Exchange than we expected. So I had a notification late last night that we were going to get a bigger room. So if you're here for Virtualizing MDOP, that's Hall 3A. We're talking about Exchange. So my name is Jeff Mieleff. I'm a senior program manager with the Exchange product group. I've been with Exchange for about 12 years, working on a number of different areas around performance and scalability. And one of my current roles is the virtualization program manager for the Exchange product. So I'm the person responsible for determining our support policy for virtualizing Exchange server products. And also helping to come up with best practices guidance for our product. So much of the white paper guidance that you see out on the web, the documentation on TechEd, those things come from me and others within the product team who help to test and produce that documentation. So in terms of what we're going to talk about today, I've kind of divided the session into 4 different sections. We're going to go through a quick review of supportability for Exchange virtualization scenarios. The previous times that I've delivered this content prior to this year, we used to spend a whole bunch of time talking about supportability and what you can and can't do. The feedback that we've been getting is that you guys understand that, so I'm not going to spend a lot of time on it. But what I am going to spend more time on is talking through what I call big problems. So one of the other things that I work on is dealing with high-level customer escalations. Large customers sometimes have problems with Exchange and pick up the phone and call Microsoft support or call Steve Ballmer. That happens too. And when those kind of things happen with the executive escalations, my team frequently gets involved and tries to help resolve things. And the 3 areas that I've listed up here are really the 3 areas that we typically see design mistakes around when it comes to virtualizing the product. So I'm going to spend a little extra focus on those 3 areas, explain what we see in the field in those areas, mistakes people have made, and how you can avoid making those mistakes in your own deployments. Then I'm going to spend a bit of time going through some of the best practices. Much of that information is also available on the web in those white papers that I mentioned, and I'll point to some URLs at the end as well, so you can see that documentation for yourselves. And then we'll close with a tools and resources section where I describe some of the other types of solutions guidance that we have available and some of the tools and programs that Microsoft provides to help make virtualizing Exchange easier. So, quick supportability review. The first point here, the Running Exchange 2010 Service Pack 1 or later, is really about some changes that we made about a year ago around virtualizing Exchange, database availability groups particularly, and support for hypervisor clustering or migration. So what do I mean by that? What I'm referring to there is high availability at the hypervisor level, right? The root machines that are running, the physical root machines that are running virtual machines in your deployments. Hypervisors typically have some form of high availability. With Hyper-V, that could be Windows clustering, where you have virtual machines that are clustered as resources that can fail over from machine to machine. And migration technology refers to things like live migration in the Hyper-V case, vMotion in the VMware case. So with Exchange 2010 Service Pack 1, we announced support for a combination of those technologies and Exchange database availability groups. I do still occasionally run into people who hadn't noticed that when we made that change about a year ago. So if you're one of those folks, this is good news. This provides you with a lot more flexibility than we used to provide in this area. And that's not the only reason to run 2010 SP1. There's lots more improvements in the product, and you should be running SP2 with the latest update roll-ups, quite frankly. It's great to stay up to date. So we absolutely support Hyper-V for Exchange. No surprise there. Out of curiosity, how many of you are virtualizing Exchange today? Okay. And how many of those are on Hyper-V? A few? VMware? All right. Another hypervisor other than those two? A few. OK. Yeah, that's useful for me for planning purposes. So in addition to Hyper-V, for those of you on other hypervisors, we also support any hypervisor that participates in the Windows Server Virtualization Validation Program. That's a program that the Windows team runs. It's sort of a certification program that allows server products like Exchange, SharePoint, SQL, others, to validate that our products that run on top of Windows will run successfully on top of these other hypervisors. So as long as the hypervisor that you're running participates in this program, both from an all-up hypervisor perspective, so VMware, for instance, as well as the specific version of VMware, as well as the specific versions of Windows that are on the list for that version of VMware or your other hypervisors, then it's supported to deploy Exchange on that platform. That's how we support those alternative platforms. But we love Hyper-V. All right, so when I think about doing a quick supportability review, it's actually easier for me to talk about what's not supported these days. We used to have a kind of a short list of things that were supported and a really long list of things you couldn't do. I'd like to think that it's the opposite now, that we actually have a really long list of things you can do, and those things that we don't allow you to do anymore are actually a pretty small list. So what's not supported with Exchange 2010 Service Pack 1 or above? Hypervisor snapshots. This would probably be one of the more critical ones. So when I'm talking about hypervisor snapshots, what I'm referring to is the ability within your hypervisor to take a point-in-time snapshot of a virtual machine and then potentially roll back to that point in time in the future, right? So I could, as an example, have an Exchange server running here, take a point-in-time snapshot, go make a bunch of changes on that virtual machine, and then roll back to the previous point in time. We don't support doing that with Exchange in production. And I'll go into some detail about why in a few minutes. Related technology, differencing or delta disks. This is the storage technology that allows a hypervisor to roll back. Right? These are disk files, VHDs, and in the Hyper-V case, VMDKs for VMware, that actually track changes. So you have a disk, and then you have a separate file that tracks changes. And those allow you to actually roll back your storage to that previous point in time as well. So for the same reasons, we don't support that type of storage with Exchange in production. Great for test, not for production. We don't support processor oversubscription in a ratio greater than 2:1. And we actually recommend not oversubscribing processors at all. So what do I mean by processor oversubscription? What I'm referring to there is the ability within a hypervisor to actually have more virtual processors assigned to running virtual machines than you actually have physical hardware to service those virtual machines. And what you're effectively doing when you configure your system that way is you're not guaranteeing that the virtual machine will have the resources it needs when your users actually demand operating power or processor power from those servers. That's the problem for Exchange. We need to make sure that you're deploying a properly sized Exchange server, and that because you've properly sized it, you know what those resources are that you need to be able to guarantee to run Exchange properly. So we don't want a properly sized Exchange deployment to all of a sudden become magically undersized because something else is using the resources that Exchange wants. That's the challenge there. We don't support applications running on the root partition. So this is more of a Hyper-V thing than an issue with other hypervisors. But as an example, we don't support having a Hyper-V machine that's running Exchange virtual machines and perhaps running Exchange on the root as well, or SQL, or something else. There's not a lot of protection from whatever's running on the root from interfering with the resource needs on the virtual machines. So this is another example of us wanting to make sure that Exchange always has the resources that it requires. We don't support VSS backup of virtual machines from the root if you're using pass-through disks or iSCSI disks with the iSCSI initiator running in the guest. It's kind of a mouthful. The specific issue there is that if you're going to use VSS to back up your systems, VSS needs to be able to perform something that we call quiescing I/O, basically stopping the process of reading and writing to the disks while it takes that kind of point-in-time snapshot for backup purposes. The connectivity between VSS and the storage that enables that to happen doesn't exist in this case. So the solution there, if you're using those types of storage, is just to back up from within the virtual machines rather than backing up from the root. That's the thing to keep in mind there. And we don't support NAS storage of VHD or VMDK files. So specifically what we're talking about there is storing these types of disk files on SMB file shares, NFS file shares, any type of file share that you would think of as being NAS storage. What we're looking for is block level storage. So if you're exposing storage to your root servers via iSCSI, fiber channel, direct attached storage, any sort of block level storage, that's absolutely fine. What we don't support is NAS file shares for those types of files. So one other quick point on supportability, and this is a fairly recent change that we've made. So the JetStress tool, hopefully many of you are familiar with it. How many of you have run JetStress before? Okay, great. I'd love to see that. I'm one of the people who created the current version of JetStress. And we love the fact that people are using it regularly to validate Exchange deployments. So years ago, when we were considering whether or not JetStress would be a good idea for virtualized deployments, we started noticing that we were seeing some very strange results from JetStress tests in virtualized Exchange deployments. And when I say very strange, what I mean is that we would see latencies, drive access latencies, that were lower in the virtual case than in the physical case. And that doesn't make any sort of logical sense. You know, you're adding some additional software, an additional layer of code and complexity in between Exchange and the storage. So if anything, it should perform a little bit worse, right? The best I would expect to see is that it's actually on par, exactly the same. That should be the best possible case, but it should never be cheaper or lower latency to access storage with virtualization in place. But that's what we were seeing. So we actually knew at that point that we had some issues with performance counters and the way that data was being presented in a virtualized Exchange deployment. So we chose not to support running JetStress on virtual machines, or at least not taking the data that you got out of JetStress and using that for any sort of sizing or reliability purpose. So things have changed a little bit since then. We've gotten a lot of feedback from customers, partners, and our field that we needed to rethink this because people had been running JetStress. The results were looking much better. So we reran a lot of this testing over the last few months and found that with modern hypervisors, we're OK. So we changed our supportability policy. You're fine to run JetStress as long as you're running one of the hypervisors listed here, basically Windows Server 2008 R2 with Hyper-V or VMware ESX 4.1 or newer. We've also updated the Exchange Solution Review Program guidelines. So our storage partners that participate in the ESRP program can now submit solutions that are virtualized. And that should provide some solutions guidance for all of you to use as a starting point for designing Exchange deployments. So we're very happy about that. So let's talk about big problems. And I'm expecting there will be some questions about these things. It's very challenging up here in a room this size for me to hear questions, especially in the back of the room, and we don't have microphones. So I'm going to ask you to hold your questions until the end and maybe come up to the stage. Or alternatively, if I can't get to you then, I will be in the Exchange Team booth from 2 p.m. till 5 p.m. this afternoon, and then it asks the experts as well. So plenty of opportunity to ask as many questions as you want. So let's talk about big problems. The first one that we're seeing a lot of in the field today is what I call the memory mess. And what I'm talking about here is dynamic memory and similar technologies. Memory overcommit is another technology that we see in this area that causes issues for Exchange. So dynamic memory is great for labs. Right? Fantastic to be able to set up a hypervisor, not worry about sizing your memory, and just let virtual machines kind of fight it out for what sort of resources they need. Fantastic for setting up a test lab. For Exchange, we're really designed to be sized properly for memory, especially the mailbox role. Right? The Exchange mailbox role has that store process that handles most of the business logic for our database layer for storing Exchange data. It has a huge database cache. We like using as much memory as we possibly can. And we don't respond well to that memory being taken away from us or to new memory being given to us if, as an example, the hypervisor decides that we need more memory. Even though we might be given more memory, we won't know what to do with it, because we don't notice that happened. And when memory is taken away from us, there can actually be a very significant performance impact that I'm going to show you in just a second in terms of some performance monitored data. So for production Exchange servers, don't do it. Don't use memory overcommit. Don't use dynamic memory. Size your Exchange servers properly based on the normal sizing guidance that we have for Exchange that we're going to talk about a little bit later. And just ensure that those servers always have that memory available to them. That's our best practices recommendation here. So if, as an example, memory is taken away from a production Exchange server, the mailbox role in particular, the end result, depending on whether you're running Exchange 2007 or 2010, and the 2007 and 2003 experience would actually be the same here if you're still on 2003. The end result there is either the database cache for Exchange is going to get shrunk dramatically, potentially down to nothing, which is going to result in your disk I/O skyrocketing, going through the roof, which will then result in disk latencies and end-user impact. Or, in the case of Exchange 2010, where we're basically fixing the database cache size to a particular size when we start up, that database cache is actually going to get paged out. It'll end up in the Windows page file. And you'll see a very similar performance impact to the other case. Instead of shrinking the database cache to nothing, now we're actually going to the page file to service some of those I/O requests. And that's not a good thing for Exchange. So what does that look like visually? I've been doing performance for many years, so I like looking at data. I'm going to walk you through what I'm showing here. And the purpose of me providing the graphs on the next few slides is really to be used as evidence. If you need to go and go through the design process for your own deployments and you're having an argument about whether or not it makes sense to use dynamic memory for Exchange, what I'm attempting to demonstrate here is that there truly is an impact to Exchange and to your end users if you do this. So you will have these slides available. You don't need to take pictures of all the slides. They're on the TechEd website, as will be the recording after the session's over. So what you're looking at here, and I'll walk you through the specifics here. The first thing that I always like to look at when I'm looking at performance data is some indication that the load on the server is basically constant. If we know that the load is constant, then any changes that we see, we know are not due to users suddenly doing more work. Right? I'm not building up queues and then delivering those queues. I don't have 500 new users that just logged into the system that are affecting the data. the load is constant. So the indicator of load that I'm using is actually the green, fairly dynamic line that's kind of all over the place in the back. But the purple line that's horizontal right through the middle, right here, is actually a linear regression, basically an average of that number over time, right? And it's a nice horizontal line. What we're showing there is that RPC operations per second number is constant. So our workload is constant over time. Processor time is also fairly constant. I mean, it mirrors the RPC operations per second. So from a CPU perspective, we're basically doing the same amount of work over time. But what we see down here on the bottom is an interesting spike. And what we're looking at is a spike in RPC average latency and RPC requests. RPC average latency is my favorite performance counter in Exchange. If you have to spend any time in Exchange trying to understand whether your users are feeling pain, this is one of the first counters you should look at. That number is an indicator of how many milliseconds it's taking Exchange to service every request that's coming in from some sort of end user software, whether it's Outlook, OA, IMAP, POP, whatever. This is the amount of time that the Exchange store is taking to service each of those requests. So what's happening is that at a point in time, right about here on the graph, something happens. And there's nothing on this graph that tells us what happened. I'm going to show you that in just a second. But we get a big spike. And this is actually graphed on the axis over on the right side. So we started out basically at 0, very fast, and then something happened. So let's figure out what happened. So in this graph, we're looking at available bytes, which is a memory counter. It shows how much memory we have available on the server. Well, we start out here, and once again, something happens. We have a dramatic drop in available memory, and that correlates very nicely with our spike in RPC average latency. And then something happens here, and we get memory back, and the system gets healthy again. So this particular slide actually tells us what happened. So there's a few counters here that I'm going to introduce. One of them is this first one, transition pages repurposed per second. That's the best counter that we know of within Exchange that tells us whether or not a particular server is under memory pressure, whether or not it's feeling pain because the operating system is having to do things to make more memory available to the applications on the system, what we call memory pressure. So this counter is 0 up until this point in time, and then it starts to go wild. So we know that we're under memory pressure. I showed you the available bytes counter earlier, which we saw drop dramatically right at this point. But the interesting thing that's happening is a change in working set. Working set is a memory performance counter that actually shows you the amount of memory for a process that's in physical RAM, not in the page file. So typically the working set for a process will be pretty static. It'll be the same over time. But what happens right here is that because we get into memory pressure, because our available bytes dropped to basically nothing, the operating system is doing everything that it possibly can to recover memory. And what it did to the Exchange store is force it to go from this amount of physical memory, which looks like it's probably about 14 gigs, and drop that down to about 5 gigs. And the way it did that was by moving all of that memory into the page file. That's probably about half of our database cache. And by doing that, we end up taking 20x, 40x, some huge multiplier amount of time to service every single request that we're getting from end users. So during this period of time, your end users are out there clicking on things in OA, and it's going to be noticeably slower returning data. You're going to build queues, right? We're not going to be able to deliver email as quickly. Basically, the entire system is going to get slower because of this. So this is why you don't want to use dynamic memory. What happened at that point in time is that another virtual machine came online that needed more resources than were previously available. Right? That VM starting up, and this is a Hyper-V example, but VMware has basically the same design when it comes to the impact on Exchange. So Hyper-V needed to provide some resources to another VM. It asked for resources from my VM here, and we gave up the resources that we could, but not in a good way. So don't use dynamic memory in production. So the next big problem that we see a lot of in the field today is what I call time traveling. So I mentioned that snapshots, hypervisor snapshots are not supported in production. So I love hypervisor snapshots. I do a lot of lab testing. I have many, many, many large-scale Hyper-V deployments at work with deployments of 40, 50 virtual machines, Exchange 14, Exchange 15, things that we're actively working on in development. And when we're working on things in development, it's really important that we have the ability to go mess with things and understand how the system behaves when we make little changes. But hypervisor snapshots allow us to then jump back to that previous point in time before we made those changes and kind of do an undo of those configuration impacts. So for lab testing, hypervisor snapshots make my current job possible. Couldn't live without them. And if you're running a test lab, which you really should be doing, where you can validate changes in production, or changes prior to putting them in production, you should use this technology, but don't use it in production. The reason is, Exchange is designed to replicate data, particularly on the mailbox role, particularly in a database availability group. And systems that are designed to have multiple copies of data and keep those copies in sync do not deal well with time travel. So if I've replicated some data to one of my mailbox servers, and I've taken a snapshot of that, and then at some point in time I decide to roll back to a previous point in time, none of the other systems in that kind of distributed group of Exchange servers are going to know that that occurred. There's no communications mechanism between servers that lets Exchange know that something happened there. So this is actually a great way to force your Exchange 2010 servers to need reseeding, or potentially to end up with databases that are unusable. So this is why we don't support it in production. Public folder replication is another great example of a replication technology that was designed way before hypervisor snapshots were really possible. And we have no knowledge within Exchange that these snapshots have occurred. So from a public folder perspective, you can get into quite a bit of trouble with this type of technology. So extreme caution is necessary in lab deployments as well. If you have a database availability group in your lab and you're doing this type of thing, you need to pay very close attention to what servers are being snapshotted at what point. Basically, you want to snapshot all of the servers in a DAG at the same time, roll them all back to the same point in time at the same time. That's the thing you need to be aware of. The other big problem that we're seeing a lot of in the field is oversubscription for CPU. So I talked briefly about our supportability guideline for that we don't support oversubscription in a ratio of greater than 2 to 1. So the challenge here is that there's this myth that when you deploy on virtual machines, that you suddenly have some additional resources that sort of appear out of thin air. Perhaps because you're getting some great consolidation effects of taking underutilized machines and putting them on a physical host and being able to take better advantage of resources. While that may be true, that when you have virtual machines that aren't actually using all the resources that they're sized for, that you can give those resources to another virtual machine. Exchange is kind of designed to use resources as it can. So even if your users aren't actively accessing the Exchange system, we still have a bunch of background work that we're doing. And we still expect that we're going to get the resources that we need when we ask for them. So while you can oversubscribe CPU, and that makes a lot of sense for potentially some line of business applications that aren't designed to constantly in the background be using CPU, things like this, Exchange is not a great candidate for oversubscription. So this is another place where if we get constrained much like the example where we were getting constrained on memory previously. You can see impacts to your Exchange system, like queue growth, increased IOPS, and RPC latency because of CPU oversubscription. So we recommend a ratio of 1-to-1 for logical processors within the virtual machines or virtual processors, depending on the terminology used in your deployment, to physical processors that are on the server. That's the thing to keep in mind. So I'm going to spend a little bit of time going through some best practices, and then we'll touch on tools and resources, and then move on to questions. So in terms of general deployment reminders for virtualized Exchange, we have no idea as a product that we've been virtualized. There's nothing in Exchange. There's no code in Exchange that goes and looks to see if you're running on a virtual machine. With one caveat, there is some code in the Exchange Best Practices Analyzer that'll go look if you're on a virtual machine. We decided we wanted to collect some statistics on that. So if you run XBPA and choose to send your feedback to Microsoft, that is a case where we are aware. But the core product itself has no idea. So from a design perspective, which we'll talk about in a couple of slides, you're really designing for physical hardware. There's nothing that changes in the way you design or deploy Exchange when you deploy virtually. Virtualization is not free from a CPU perspective. I know that there's been some marketing over the years that Exchange runs better on some virtualization platforms than it does physically. It's not true. When you deploy virtually, there is some CPU cost added on any virtualization platform. There is some cost added. With Hyper-V, we see around a 10 to 12% increase in CPU. With VMware, I'm not going to quote their numbers. I'm going to point you to their guidance because I'd much rather use their testing from their labs where they know the product, their product much better than we do. But they have some guidance as well on what their impact is, and we would recommend that you use their guidance for sizing if you're deploying on VMware. So when you size for Exchange, what you're having to do is size for physical and then add extra CPU requirements because you're virtualizing. So that's that additional cost that you need to be aware of. Once again, don't oversubscribe anything. I'm going to say that a few more times because I really want to drive that point home. We don't want you to oversubscribe anything. 1-to-1 ratios. So the Exchange product is really architected for scale out. Right? In Exchange 2010, we like the idea of big database availability groups, lots of smaller servers. We think that that actually provides the best possible high availability with Exchange. You can lose a whole bunch of servers potentially and still keep servicing all the requests from your users, have your system remain up, and deal with those hardware failures in an intelligent way. When you scale up, you're basically creating what we call a failure domain. And what you're doing is creating the possibility of a much larger impact from a server failure. So if I put 30,000 users on a server, not saying that you should by any means, to be clear, if that server goes away, even if I have another redundant server that has copies of all that data, when I lose that physical server, I now have 30,000 users that need to reconnect. And my CAS servers aren't going to like that very much when those 30,000 users just all of a sudden are hammering those CAS servers trying to reconnect. And that's going to impact my entire set of users. That's just one example of why we think that the scale-out model is significantly better. Basically minimizes the impact when failure occurs. So when you virtualize, more often than not, you're using scale-up hardware, big machines. Right? You're using 24-core, 48-core machines, potentially significantly larger. The challenge there is how you deploy Exchange on those servers and use the scale-out model that we think provides high availability, yet still take advantage of that hardware. And there's ways to do it, and we'll talk through some guidance about how you place virtual machines on those servers in a second. But the key here is that you really want to avoid what we call, putting all your eggs in one basket. You want to spread out Exchange virtual machines as much as possible across these physical hosts. That's the key. So in terms of sizing for Exchange and for virtualized deployments, as I mentioned, we start with the same process that we use for physical servers, right? We start with the mailbox role requirements calculator, which is a great tool. Hopefully all of you have had an opportunity to take a look at it. It's available on the Exchange team blog, and I have a pointer to it in the deck at the end. That allows you to actually put in your user counts, the type of utilization that your users run against Exchange, and your specific requirements, how you're going to back up, what type of storage you're going to use. And it will actually show you the requirements for number of servers, the way that databases should be laid out on those servers, the I/O requirements, the capacity requirements. All of that information is applicable to virtualized deployments, just as it is for physical deployments. It's the exact same information that you're going to use for sizing, regardless of virtual versus physical. And that information can then be used with the other guidance that we have published on TechNet that describes how to size your client access servers, your hub transport servers, and your unified messaging servers. Nothing changes there, with the exception of that CPU overhead that I mentioned a few minutes ago, right? That 10 to 12%. The mailbox role requirements calculator actually has a drop-down box in it where you can say whether or not you're virtualized. And really all that does is add 10% to the CPU requirement. My friend Ross, who wrote the calculator, likes to make a big deal out of that as a feature. But in reality, all it's doing is adding 10%. It's pretty simple math. So once you actually have figured out what your requirements are, how those servers are sized in terms of CPU, memory, and I/O needs, then you need to figure out where those virtual machines are going to live, what physical hosts they're going to run on. And we'll talk about that on the next slide, I believe. You also need to, if you're going to run live migration or vMotion, figure out how that's going to impact where those servers are going to live and what the impact on network is going to be. Right? If you're running live migration or running vMotion, you're going to have increased network capacity needs between those physical servers. And we'll talk about that in a minute as well. So, going to keep hammering it home. Don't oversubscribe. Right? We want to make sure that the resources that the calculator spits out and that TechNet prescribes are actually being delivered to these servers. So as of Exchange 2010 Service Pack 1, we began supporting virtualization of our unified messaging role. Out of curiosity, how many of you are virtualizing UM today? Okay. And how many are actually interested in doing that in the future who aren't doing it today? A few more? Okay, great. When we started talking about this about a year ago, when we made the support change, I didn't actually really see anybody interested in doing it, which was unfortunate because we did a whole bunch of testing to make this possible. But I'm happy that you're actually wanting to do this. So the challenge with unified messaging is that when performance is bad on a unified messaging server, it's very obvious to end users. If I pick up the phone and call into a unified messaging server, let's say I'm using Outlook Voice Access and I want to have the system read me my email or tell me what my next appointment is or let me cancel some appointments. I love the clear my calendar command. It's a great feature in Exchange. If the unified messaging server is experiencing a performance problem, I'm going to hear really choppy audio, really bad sound quality. It's not like if I'm connecting to Exchange over OA or Outlook cache mode or something like that, where a couple of milliseconds of latency aren't going to be visible to me. I'm not going to notice that. But if there's a few extra milliseconds of latency on that voice channel, I'm going to hear it. And it's going to make me not want to use that anymore. So the challenge here when you virtualize unified messaging is to make sure that you're never going to impact latency such that you get bad voice quality. That's why we have some very strict requirements for providing resources to unified messaging virtual machines. We require a minimum of 4 virtual processors, and we require that access to the physical processors behind that is always available. What that means is that you can't really oversubscribe anything running on that physical host. Or you can use resource reservations that are available in basically all of the hypervisors that you're using today. to provide full-time access to those processing resources. So that's the key there. Network requirements are also an issue with just as they are in the physical world. You need to make sure that you have the right level of bandwidth and low enough latency to service the workload. So in terms of storage, we do recommend that you keep your Exchange storage on separate disk spindles from the OS, from the operating system. This is actually, generally a good recommendation across the board, virtual or not. What we want to make sure of here is that if you lose your OS drive storage, that Exchange doesn't get into a weird state where where the operating system doesn't have access to its file system anymore. We want to make sure that if that storage is going to fail, that Exchange actually can handle that fail in a good way and deal with the failover from a database availability group perspective well. We want the failover to happen quickly, seamlessly, with no end user impact. And having that separate storage helps to ensure that that failover happens properly. We do require that Exchange actually use either fixed VHDs or VMDKs, not dynamic ones that grow over time. SCSI pass-through, or RDM for those of you on VMware, or iSCSI. Those are basically the three methods that are available to provide storage to Exchange virtual machines. We do recommend using SCSI pass-through because we see some performance benefits for doing that for Exchange data storage like SMTP queues, mailbox server databases, and log file streams. The others are will certainly work fine. There's no reliability issue with them. It's just we see a minor performance increase for going with SCSI pass-through. So that's the best practice. If you're using Hyper-V live migration, there's a feature in Hyper-V called cluster shared volumes that actually improves the live migration process, or the speed at which you perform a live migration, fairly dramatically from an Exchange perspective. And I'll talk about why in just a second when I talk about live migration and vMotion. So that's the recommended storage method or storage deployment method if you're going to be using live migration. If you're using iSCSI to provide storage to Exchange, basically all of the standard best practices for iSCSI apply. So typically you'll deploy with jumbo frames. There are types of hardware that allow you to offload some of the iSCSI processing from the server CPU. You'll typically deploy with dedicated network interface cards, usually more than one of them, so that you can fail between them if network failures occur. So all of those best practices apply to virtual as well as physical. This is kind of some old guidance, but historically, if you ran the iSCSI initiator in the virtual machine guest, the network drivers from a few years ago, from Hyper-V, VMware, et cetera, didn't used to support jumbo frames and some of these other technologies that are important for iSCSI performance. It's no longer true. So in general, running iSCSI in the guest is just fine. You just need to make sure that you're enabling those technologies. And I mentioned when we were talking about supportability at the start that all Exchange storage must be block level. So this is just a reminder of that. No SMB, no NFS, no any other NAS technology. Exchange needs to use block level storage. And that's for any place that we're storing Exchange data. You're fine to have your OS drives be VHDs or VMDKs that are stored on NAS. That's fine, totally supported. So for virtual processors, there is some old guidance still out there that we still see people referring to every so often that suggests that because of scalability issues with a particular hypervisor, it actually makes more sense to deploy 4 single CPU machines than it makes to deploy 1 4 CPU virtual machine. Exchange doesn't do well on single processor machines. We're designed to take advantage of multiple CPUs. We're designed to scale up pretty well, actually, from a multi-CPU perspective. So even though I'm sure we'd love to have 3 additional Exchange server licenses for those additional servers. It's not the right way to deploy. You want those servers to be as big as they possibly can be from a CPU perspective. The other important thing to remember that we see tripping people up occasionally is sizing based on hyperthreading being enabled from a CPU perspective. So I might be deploying on a 24-core physical host that has hyperthreading enabled. So I see 48 processors. Well, I don't have 48 processors. I only have 24. And that 24 number is what you should use when you're sizing. The hyperthreading gives you some benefit for Exchange and some benefit for pretty much any workload, but it's not 100% benefit. It could be 20%, could be 10%. It's going to depend very much on what those CPUs are doing at a particular point in time. So when you're sizing, you can't rely on hyperthreading providing you with anything specific. So you size as if hyperthreading wasn't there. That's the important thing to remember. So everybody wants a private cloud these days. Cloud is certainly a term that's being used heavily at conferences like this and maybe being overused in some ways because it's not, I think, terribly well defined. It's a little ambiguous. And in terms of what I'm discussing today, just to be clear, what I'm referring to is a set of physical hosts that are being used in sort of an infrastructure as a service perspective. So I might deploy a large pool of physical machines that are being managed as kind of a computing unit that I'm going to carve up for particular applications like Exchange, like SQL, like SharePoint, right? So Exchange, as I've mentioned many times today, likes to have access to the resources that it was sized for whenever it wants them. When you're deploying a private cloud, typically you're going to be oversubscribing some things, or you're going to be sharing some resources regardless, right? So if you're sharing storage, for instance, between Exchange and SQL, you want to make sure that you're running on separate spindles on that shared storage. You want to isolate the I/O as much as possible so that your SQL workloads aren't going to impact your Exchange workloads. We kind of go back to the Exchange 2003 days, or 2000 days, where Exchange was very heavily dependent on large shared storage deployments to be able to provide the performance that the application required. And we ran into huge problems in customer deployments when that storage was shared by other workloads that were competing for resources simultaneously. Cloud deployments, private cloud deployments, take us right back there. So we want to make sure that we're not revisiting the past and running into issues with resource contention between different workloads. So at the same time that we want you to isolate things to ensure that Exchange has the resources it needs, there's a little bit of a balance, a little bit of a balancing act that you need to play here. Because we want Exchange to be spread out on as many of those physical servers as possible for high availability. So on the one hand, we don't want you to share resources, but on the other hand, we want you to use as many of those servers as possible. There's no one answer for what that balance should look like. It's going to be very dependent on your particular scenario if you're deploying a cloud, but it's just something to be aware of. And I'm more than happy to talk through your specific scenarios if you want to talk after the session or ask the experts or in the booth today or tomorrow. And we can talk some more about what that might mean for your deployment. So host-based failover clustering. Let's talk about what that is and why it matters for Exchange. So what I'm referring to here, like I mentioned when we were talking about supportability at the beginning, this refers to hypervisors like Hyper-V or VMware or others, and clustering a virtual machine so that if there's a failure, that virtual machine can move from one physical host to the other automatically. Fairly straightforward, right? We see a lot of customers, particularly when Exchange 2010 came out, who wanted to deploy host-based failover clustering to provide high availability for Exchange. There's a very straightforward reason for this that I think we kind of expected within the product group. And that is that when we released Exchange 2010, we removed a storage option that many of you who've been deploying Exchange for years were familiar with. That's what we called single copy cluster in Exchange 2007, and what we kind of just called clustering or high availability in previous releases, where you had one copy of your mailbox database, and that copy was on shared storage, and that shared storage could be accessed by multiple mailbox servers. So if a mailbox server failed, the access to the storage moved to another machine, and that other machine took over where the failed one left off, right? So when 2010 came out, we eliminated that deployment method, that type of storage deployment. And what some of our partners in the storage industry realized is that this is actually a great way to deploy Exchange and still take advantage of that storage design. Instead of having Exchange failing over, or the access to the storage moving between Exchange servers, instead, you just kind of take it up a level, add a hypervisor layer into the mix, and you now have virtual machines that are just failing from one physical machine to another, but the storage is deployed in the same way. I have a single copy of my virtual machine storage, and it fails from one physical host to another. So the key thing to be aware of here is that this isn't what we call an Exchange-aware solution. There's no communication between Exchange and the hypervisor that allows Exchange or the hypervisor to provide true high availability. The only thing you're really getting here is protection against a hardware failure on the physical host or a network failure on the physical host. If Exchange has a problem that in an Exchange high availability deployment would actually result in a failover or some sort of switchover activity, that won't happen with this type of deployment, right? Exchange will just happily be doing what it's doing, and your end users may not be able to get to their mail, may not be able to access the system, but you won't actually see an automated failover. So the key here is that if you want to deploy in this way, we recommend doing it in combination with a database availability group, not instead of. And I'll show you what that looks like. So visually, if we just take the very simple case of a host-based failover clustering deployment with some shared storage, 2 physical hosts, and 1 virtual machine over here on the left. So without considering a database availability group, this is what it looks like, right? I lose the host on the left, and host-based failover clustering will bring up that virtual machine on the other host. Very simple, very straightforward. What we'd rather see is this type of deployment, where now I have 3 physical hosts. It says Hyper-V here. Could be any other hypervisor. I have 3 physical hosts, and I have 4 virtual machines, 2 mailbox servers, 2 CAS and hub servers. And on my mailbox servers, I have 5 databases in a database availability group. That's the sort of white oval that's surrounding the databases. And I have 2 active copies on mailbox server 1. Database 1 and 4 are active here. And 3 active copies on mailbox server 2. Database 2, 3, and 5 in orange here. So using the same example that I just showed, where I lose one of the physical machines, what's going to happen here? So I lose Hyper-V host 1. Well, those 2 virtual machines that were running there are obviously going to go away as well. Host-based failover clustering hasn't done anything yet. But Exchange, within the database availability group, has realized that we lost mailbox server 1, and so we activated the copies that were active on mailbox server 1 now on mailbox server 2. So my users can still get to their mail. Exchange is still up and running. Presumably I had a load balancer sitting in front of the 2 CAS hub servers. So CAS resources are still available. I still have users able to access Exchange through CAS and hub server 2. And now at this point, host-based failover clustering is going to bring up the virtual machines for mailbox server 1 and CAS hub server 1 on the other physical host. The other thing that's going to happen when that occurs is that the database availability group will start replicating again, right? So the changes that are occurring on mailbox server 2 for all these active copies will start replicating to the passive copies on mailbox server 1. That's a good thing. That means that we're keeping mailbox server 1 up to date, right? I wouldn't have had that without manual intervention if I didn't have host-based failover clustering. So that's a benefit that this provides to the DAG. And that means that if I then lost mailbox server 2, I'd have up-to-date data on mailbox server 1. So we bring up Hyper-V host 1 at some point in the future, and an administrator would have to go in and rebalance the database copies across the mailbox servers to even out the load a little bit. That's the scenario for a physical host failure where we're using both DAG and host-based failover clustering. You get the best of both worlds there. So virtual machine migration. And what we're talking about here, once again, is live migration or vMotion. We see lots of customers very interested in doing this. It's a very cool technology, right? The ability to take a running virtual machine on one physical host and move it to another physical host without any end user impact, right? I have no idea that that machine just moved from this computer to this computer. My access to it continued to operate while that occurred. Very cool technology. People do this for a number of reasons. Maintenance of physical hosts is certainly a great one, right? Comes time to patch that physical machine, just vMotion or live migrate all the virtual machines off of it to another physical host. I can do whatever I want to that physical machine at that point. I can reboot it as many times as I want because it's not servicing any production workload. We also see it being used to rebalance workloads. So if I have some servers that are running a little heavier than they should be, maybe I can take one of them, some virtual machines that are running a little heavier than they should be. Maybe I can take one of those virtual machines and move it to a more lightly loaded physical server. And my users get a better experience as a result. We also see people doing what we call green IT, or off-peak virtual machine consolidation. That's the idea that maybe on the weekend you know that your workload reduces by 50%. So maybe you can temporarily consolidate some of those virtual machines that you have on a smaller number of physical hosts over the weekend and physically turn off some of those hypervisor hosts. Save some money, right? Save some power and cooling. That's less frequently brought up, but we certainly know of customers that are doing that today. So what does that look like with Exchange? And we'll compare this to the example that I used a minute ago. So let's virtualize these four Exchange servers. In this case, we're using some shared storage, and we're now on 3 hypervisor hosts, just like before. So if I wanted to live migrate mailbox server 1 from Hyper-V host 1 to Hyper-V host 3, what does that look like from an Exchange perspective? It looks like this, hopefully. There's no change in database copy activations. The database availability group, that white oval, didn't go anywhere. It's still there. We're still replicating changes between the two servers. Everything is working exactly as it was when mailbox server 1 was running over on the left on Hyper-V host 1. Right? There's no difference, no end user impact. The challenge in making that happen is ensuring that when you actually perform that migration, that the very brief outage period, which is typically less than a TCP timeout, effectively, is short enough that the mailbox server doesn't get evicted from the cluster. So if that blackout period or brownout period, whatever you want to call it, is too long, the other mailbox servers in the database availability group will notice that the mailbox server is offline, and they will stop replicating to it and evict it from the cluster. So that when it comes up in its new location, it won't actually be part of the DAG at that point in time. You may end up having to perform some manual remediation to get it back up and running. You may end up having to do some manual reseeding of databases if that occurs. So not a good thing. Ways to actually ensure that that doesn't happen are a few, and we'll go through that. Cluster shared volumes for Hyper-V is one great way to help mitigate this problem. CSVs help to minimize that outage window as storage switchover occurs between physical machines. The other thing that you can do is actually change the timeout for the heartbeat within the cluster. So you can actually relax it a little bit. Take it from 5 seconds to up to 30 seconds if you need to. We recommend not going above 30 seconds. But the way you do that is within PowerShell on your mailbox servers. These are some cluster settings that we've documented that you can change. By default, same subnet delay is 1,000, same subnet threshold is 5. What that basically means is 5 tries of 1,000 milliseconds, or 1 second each, before we determine that a host is down. So you can change that to whatever combination multiplies out to 30 seconds on the maximum. You want to keep that as low as possible because that's also used to determine when machines have actually gone offline that you want to respond to. So if you make this a very large number, what you end up with is a case where if a mailbox server actually does go offline, Exchange won't respond to it properly for that time period. So you get into a case where high availability isn't really high availability anymore. So keep that as low as possible, but you can increase it up to 30 seconds if you need to. You definitely need to consider network interfaces when deploying live migration or vMotion. We recommend, I think, in our best practices guidance, a dedicated gigabit NIC on all your host machines for this purpose. Certainly go bigger if you can. 10 gig Ethernet is a wonderful thing for this. The more bandwidth you have available to this process, the faster it'll go. And with the newer hypervisors, like Server 2012 that's coming out shortly, you can migrate multiple virtual machines simultaneously, which is a nice thing to be able to do, particularly for like the patching scenarios that I mentioned. So in terms of locating virtual machines, and we're almost done with best practices before we'll talk about tools and take some questions. So as I mentioned, in terms of spreading out virtual machines across hosts as much as possible, placement of virtual machines, very important for high availability. You want to take advantage of as many machines as you can. You don't want to co-locate DAG copies on the same physical machines. This is a mistake that we see made fairly frequently. So within a DAG, you can have up to 16 copies of a database, right? If you put multiple copies of that database on the same physical host, when that physical host has a problem, you've just lost multiple copies of the database. And basically, there's no point in having multiple copies of the database when that occurs. So if you have 3 copies of a database, you want to make sure that the mailbox servers that are hosting those copies are on 3 different physical machines. And then you'll actually get the benefit of having those copies. Unlike in a physical deployment, when you co-locate Exchange mailbox and Exchange hub transport roles, we don't actually know in a virtual deployment that a mailbox server is running on the same physical host as a hub server. And Exchange actually makes some changes in the way we submit mail when your users send messages in a physical deployment when hub and mailbox are running on the same server. Because there's a kind of a corner case where in that submission process, we can end up with a message getting basically lost if that server dies at exactly the right moment in time. To avoid that in the physical case, we actually submit always to a hub server that's running on another host. We never use the same, we never use hub on the same physical host as mailbox to submit outbound messages. In the virtual deployment, if that physical host goes away, we are susceptible to that rare corner case where you might lose that message. And the user might have to resend it. So something to be aware of. And if that is a concern, we recommend isolating hub and mailbox virtual machines from each other on your physical hosts. That's the way to avoid that. So in terms of tools and resources, I mentioned the server virtualization validation program at the beginning around supportability. This is how we provide supportability for third-party hypervisors like VMware, Citrix Zen, et cetera. This is the URL to go to if you're interested in whether or not a particular hypervisor is supported with Exchange. And this is updated fairly frequently as hypervisors are submitted into the program for consideration. We have a number of Exchange 2010 tested solutions. Some of these are getting a little bit old, so the hardware that they were validated on may or may not actually be the hardware that these vendors are selling today for Exchange. But these are still very valuable documents for one particular reason. Each one of these actually walks through an entire Exchange design process. Walks through the requirements, the business requirements, walks through all the decision points that were made along the way as the people designing these solutions were considering what type of storage made sense. What RAID level to use if they're using RAID, how to size network bandwidth, et cetera. Every decision point is documented with the trade-offs that are associated with that decision point. So if you're doing an Exchange design, taking a look at these documents may give you some great ideas of things that you hadn't considered and might want to consider in that process. So even if the hardware isn't necessarily relevant to what you're doing, highly encourage you to take a look at some of these. All of these listed here are virtualized on Hyper-V. We have some physical tested solutions as well, so you can compare and contrast the process of deploying on virtual versus physical and the design questions that come up. All of these were tested with full deployments, all users created, databases fully populated with load gen and tested for days on end, with all of the test results, all the performance data included in the test reports. So great starting points for Exchange solution design. In terms of support guidance, support guidelines, the documentation that we have on TechNet is the official location for getting supportability guidance for Exchange 2010. And that URL that's up there is actually fairly new. We used to publish the guidance as part of the system requirements page for Exchange 2010. Virtualization has become a bit more of a something that needs its own page in terms of the volume of the information that we're publishing. So it now has its own dedicated page on TechNet that we update fairly frequently. So that's the place to go if you're interested. And the Server Virtualization Validation Program Support Wizard, it's a mouthful, is a tool that allows you to put in what Microsoft application you're running, what hypervisor you're running, and what operating system you're using. And it will tell you whether or not it's supported or not, and whether there's any concerns you need to be aware of, any features that may or may not work or may or may not be supported. So Support Policy Wizard is a good quick reference for figuring out if you're supported. So in terms of related content, on Friday, the Link team is talking about virtualization as well. I know if you're deploying Exchange, you may be considering Link. So this would be a worthwhile session to check out. Hopefully you made it to the Windows Server 2012 Hyper-V session as well, so you have an understanding of what's coming. There's a lot of very exciting new features and functionality coming in Server 2012 in this area. And I'm going to kind of breeze through the track resources real quick here because I do want to point out one particular thing. So we are having a dedicated Microsoft Exchange conference at the end of September. The MEC conference is back this year after a 10-year hiatus. This is going to be the one place that you can go initially for Exchange 15 information. We're not able to talk yet about the next release of Exchange that is going to be coming out soon, but we will be talking about it at MEC in very great detail, and it'll be a great opportunity to meet with folks from the product group and other areas of Microsoft and get a lot of great information about Exchange and have a great opportunity to provide feedback to us. So highly encourage you to come to MEC if you're interested in Exchange and particularly the next release. So with that, I thank you for your attendance today, and I'm more than happy to take questions if you want to step up. So thank you.